Hello and welcome everyone. This is our part 2 video on absolute value inequalities. You didn't really think we were just going to be coloring that quick the whole time, did you? Hope not. It's time to bring inverse operations back into the fold. So just because we have an absolute value doesn't mean that there are other numbers around it. And so it's our job as mathematicians or math students to isolate that absolute value so we know exactly how close we're supposed to be to 0 or exactly how far we are away from 0. As always, if I type something or I draw something, feel free to pause the video and write it down because I'm just going to be talking, but this is the rare opportunity where you can actually pause what I'm saying. So use that to your advantage to write down the notes. Okay, looks like it transitioned. So we're going to do a short little comparing and contrasting for what we did before and how nothing has really changed. It's just that now we have to think about what absolute value means when we are solving our questions. Let's activate our pen tool. So in the past, you may have seen something like x plus 7 less than 15. So think to yourself, what would you do on both sides to solve this? And I wait, and you would probably say, well, I would subtract 7. So x should be less than 8. And guess what? That's what we'll do when we see the 7 outside the absolute value. We'll take away 7 from both sides. And now we have the absolute value of x is less than 8. Now, based on the last video, if we're less than 8 away from 0, this means we want to stay close. We can go to the left, we can go to the right, but we must be within 8 units from 0. So we'll put an open circle at -8, open circle at +8, and go ahead and shade in between. Second example, 3x is greater than 12. Well, that's a multiple. So how did we make a multiple go away? You would divide. Divide both sides by 3. X is greater than or equal to 4. So if there's a 3 multiplied outside your absolute value, go ahead, use your inverse operation of division to take care of it. The absolute value of x is going to be greater than or equal to 4. Well, when the absolute value is greater than, this is saying stay away. You must be at least 4 units away from 0. And since there is the or equals to bar here, this means I'm going to be using in filled-in circles. So the absolute value is greater, meaning I'm going to be big. I'm going to push away. All right. Third example. Well, this is a classic case. In this case, we have 2 inverse operations. So this is when we need to ask ourselves, which inverse operation should we remove first? We got a 2, which is times, and we have a -6. So right now, try this on your own. See if you use the correct inverse operation first. Of course, you can pause the video. But if you didn't, hopefully, you added 6 to both sides. 2x greater than 10. Divide both sides by 2. X would be greater than 5. Now I'll spare you writing it down here as well. We would get the absolute value of x is greater than 5. Meaning we have to be 5 away from 0. We will use open circles because there is no bar. And we will push away. Greater than 5. Okay, excellent. Don't forget that sometimes when we're in the process of solving an inequality, we might have to flip the inequality sign. So if you had x less, it'll turn into x greater, and vice versa. If your original problem had x greater, well, now it's going to flip to x is less than. So right now, think to yourself, what would cause, that was not the best one there, what would cause us to flip the inequality sign? Now that you've given that some time, let's see. So we will flip the inequality when we multiply or divide by a negative number. Keep in mind that we are going to divide more than we will multiply. And that's just a product of the types of problems that I give you, but they are equally likely mathematically. So I will do question 1, but I encourage you for question 2 and for question 3, please try to solve these on your own and see if you match up with what I do. And again, you have the power to pause, so I would go ahead and I would use that power. Okay, so question 1. Well, I see I have a minus 9, so I'll add 9 to both sides. 6 absolute values are greater than or equal to 24. Divide by 6, divide by 6. The absolute value of x is greater than or equal to 4. If the absolute value is greater, that means I'm going to push away. So we got greater than, and we got the bar underneath. So that means I will put a filled in dot. Filled in dot, filled in dot, pushing away. All right. Moving on to question 2. Oh, I know some of you are worried about this, right? X is on the other side. But it doesn't really matter. Whenever we read an inequality, we read it from the side with the x on it. So this isn't really going to change our solving process. It's just written on the other side. Okay, well, this 8 is positive. So I will minus 8 from both sides. 12, and we got 4x. The 4 is being multiplied by the absolute value, so I will divide. And that gives us 3, and here you have it. So again, you want to read from this side. Is the inequality trying to eat the absolute value, or is it not? It is not. So this is a less than example. Please stay close. Still filled in dot. Fill in, please. Thank you. Okay, so I have to be less than 3 away from 0. So I would fill in between. Third example. Again, please pause the video, try it on your own, give it a good try. And if you have unpaused, well, now I'm going to do it. Minus 8 from both sides. Negative 5 absolute values of x less than, oh, what would this be? This would be 35. Now I would divide both sides by negative 5. And this is the special exception. We are dividing by negative. So when I have the absolute value of x, the inequality turns around, and I have to be greater than negative 7 away from 0. Now, this is a funny situation. You have to be greater than negative 7 away from 0. This technically means that everything works. Because you know what's greater than negative 7? Negative 5. You know what's also greater than negative 5? Negative 1. And what's greater than negative 1 is 0. So you can even be 0. And you could shade to the left. And you could shade to the right. In fact, this produces all real numbers. So anything works. That's interesting.